I love it.
It's gross.
Fried is the way to have it, though. If it's slimy, you cooked it wrong.
I've had a traumatic experience with Goobers.
What do you mean traumatic? Someone throw it at you?
All right. Write the area of a circle as a function of the circumference C. So, first of all, what do we know about area of a circle?
2 pi r. Wait, pi r squared.
You keep saying circumference.
Pi r squared. What about circumference?
You got this, Joe.
2 pi r.
All right, so we want area of a circle as a function of the circumference C. So, what is the only thing these two have in common, variable-wise?
Pi r.
Or.
R. So, I'm going to solve for R.
Pi is the number.
So, R is what?
We gotta separate it.
Or R squared is what?
Pi radical
A
pi.
divided by pi.
A over pi. What's R over here?
R equals
C divided by 2 pi.
Okay. So now I can do this. Write area of a circle as a function of the circumference C. So that means in this equation for R, I'm replacing it with C over 2 pi
Okay.
because I want it as a function of C, which means I can't have R. So part A equals pi times C over 2 pi squared, also known as 1/4, or well, 1/4 over pi, or 1/4 pi, I guess I should say, times C squared. So this is area as a function of circumference.
Wait, how did you get one? Oh, you multiplying?
I squared this,
Oh.
and then I canceled one of the pi's out
Oh.
just to save a step. Now, the other thing I could have done is I could have set like these two things up here equal to each other. So I could have said A over pi is equal to R squared, which would have been C squared over 2 squared pi squared, and done it that way. But that's more work when you can just solve for R and plug it in. But we might need this later. It's like Toodles from Mickey Mouse Clubhouse.
It's our mystery mouse tool.
This is a tool we can use later.
Oh my gosh. Gross.
Yeah. You need to like row down and go back to my childhood.
Apparently you didn't have one.
What kind of child likes Mickey Mouse? What do you mean?
I didn't want
I watched Mickey Mouse.
Sorry to hear that.
All right. Find the instantaneous rate of change of the area A with respect to circumference C. What might we need to do?
Oh.
What was the question? We could use
The instantaneous rate of change.
Oh, you used the
the other one.
F of.
Wait.
If I have a function, how do I get instantaneous rate of change?
You do the F of A plus H minus F.
Take the
Derivative.
derivative.
That's basically what I said.
So, I'm taking the derivative of this. So, dA dC. Okay, this is the derivative of A with respect to C. Is equal to, what would the derivative of this be?
Oh, it would be. Wait a second. Would it be 1 over times C?
Yep. Or we can say C over 2 pi. I want it to, All that's the same thing. Are we tracking
Yes.
everyone? Okay. All right, now, using that, evaluate the rate of change of A at C equals pi and C equals 6 pi. So for C equals pi and C equals 6 pi. So we just, now that we have the derivative, we just replace C with whatever value they want. So this is going to be pi over 2 pi, which is
Wait, 1 over pi. Wait,
Hold on, you lost it.
1 over pi.
C pi equals pi.
I replaced C with pi up here.
So 1 over pi.
So that would be.
I have a pi on the top and 2 pi on the bottom.
These are going
Yes, it's 1/2.
You were thinking it's like there was no x. It wasn't like pi to the squared.
I was like, what is happening? I was like, he's canceling pi in 2. I'm not sure where that's coming from. And then at 6 pi, we just replace C with 6 pi over 2 pi. And this one is...
Wait, I caught this one. Nobody answered. Stop. I got it. 3 pi. Wait, 3.
Oh my god!
It's 3.
Just 3. The pies cancel.
Who let this bear? Don't even.
You burnt the kitchen down.
Bruh. Okay. And the last part of question 2, D,
I got
says,
one back.
if C is measured in inches and A is measured in inches or square inches, what units would be appropriate for DADC?
Wait,
Inches per inch.
Inch,
Wait, inches squared per inch.
inch what?
Inches
So
squared per
DADC, A is inches squared, C is inches, and so they leave it this way, but if you wrote it as inches, like ultimately,
Yeah.
You.
that's fine.
But like technically
I
it's
said
inches
that.
squared per inch.
I said
Yeah.
the thing though. I said the inches.
Yeah,
Whew, one problem down. And only a few mistakes.
but they were all me.
Alright, 4 is the same type of problem. A square of side length S is inscribed in a circle of radius R.
Sure.
Well, don't you believe that?
Oh,
I made it just
Circle, guys.
E.
And
That's
radius.
pretty.
Not the shape inside the shape.
Yes.
No.
What is happening?
Nathan's making weird noises.
I can tell. Alright, a square of side length S is inscribed in a circle of radius R. So that means the diagonal of the square, or half the diagonal of the square, is R. I feel like we did this the other day.
I was.
There's no circles on my paper.
Then we did this in another class because I literally had this exact same
That would make
thing.
sense.
I wasn't in that class.
Good job, Christian.
Did you say there's no circles on your paper?
Yeah.
Alright, so I have a square inside of a circle, okay? The square has side length S. The radius of the circle, which happens to also be the half of the diagonal of the square, is radius R. So I have R, R, and S. What do we know about this shape right here?
It's a triangle.
It's a triangle. What type of triangle?
Of equilateral.
No.
Right, no.
Isosceles?
Right.
Oh, right. That's what I meant.
Right.
Well, yes, also isosceles, I guess, technically.
Right.
I was like, the letters were the same.
It could potentially be equilateral, but we don't know that yet.
Yeah, we don't know.
Yeah, boo.
No, it is.
That's a-
All right. Write the area of the square as a function of the radius of the circle. Alright. Area of a square in general is what? Let's do this.
Oh,
S, yeah.
S.
Wait.
Area of a square is S squared. Area of a circle.
Wait, I got it.
You got it, Josh.
Pi r squared.
I know.
Uh,
Pi r squared.
Beginning to lose hope.
Getting to.
wow.
Ew, that was loud.
Alright.
Why is my car like that?
As a function of the radius of the circle. Any idea what we might need to do? It was pre-cal that we did this, I remember now.
Wait, can you read the question again?
Write the area of the square as a function of the radius r of the circle.
Okay.
So basically, I need to rewrite S in terms of r's.
I don't know how to do
What do I know about this shape?
Ooh, could we? It's a
It's a
triangle.
right
R
triangle.
squared plus R squared equals S squared.
Okay.
Yeah.
So S squared is equal to R squared plus R squared. So that means that S is equal to the square root of 2R squared, meaning that S is equal to what?
It's r.
It's equal to that.
Wait. Is it
2 R.
I'm taking R out, so S is equal to R squared root of 2. So now, what might I do to find the area of a square as a function of R? What'd you say, Nathan?
Yeah,
Plug it in. It's like a Glade commercial. Y'all aren't too young to know that, right?
What'd you
No,
say?
what?
I said it's like a Glade commercial.
Glade. Like
Glade, like the scented wall plugins.
Oh, yeah.
Plug it in, plug it in. Is their slogan? No,
So-
maybe not.
Oh,
Okay,
square.
never mind.
No, I have one of those, like the pluggy thingy.
So what does A end up being equal to?
It equals 2r squared.
Yeah.
2R squared. So that's my area as a function of radius. Yes, that's part 1. Part 2. Find the instantaneous rate of change of the area A with respect to the radius r of the circle.
Ooh, we did this.
Derivative, which means what? dA dr
dr.
equals.
So we're taking the derivative of what we just got, right?
Yes, the derivative of this.
So it would be 4r.
4r. C. Evaluate the rate of change of A at r equals 1 and r equals 8.
Okay.
We're doing what?
Evaluating for r equals 1 and r equals 8.
So r equals 1, so we put in the 1 for r, right?
Yeah.
So it just equals 4. And then the other one put in 8 for r, so it equals 32.
Yep. And the last part, if r is measured in inches and a is measured in square inches, what units would be appropriate for dA dr?
Inches
squared per square
inch.
Inches squared per inch, aka inches.
Is there a difference between inches and square inches?
Like how big is a square inch compared to an inch?
A square inch is just inches squared.
Oh, wait.
It's area.
That's true.
Inches times inches.
So you have to be. No, but like, one square inch is just 1 inch because 1 squared is 1. Right? Is that how that works? I don't know.
I don't think
Let's do
so.
flooring.
I'm not here to learn about flooring.
One
So.
square is one.
All right, the next thing that we're gonna be doing is
Actually, but
basically using this formula here.
few people.
Okay.
It's not being.
I didn't even say names.
So it's a word problem.
Well, that was a weird sound.
You've been making a lot of weird sounds back there.
All right, draining a tank. The number of gallons of water in a tank T minutes after the tank has started to drain is Q of T is equal to 200 times 30 minus T squared. How fast is the water running out at the end of 10 minutes? And what is the average rate at which the water flows out during the first 10 minutes?
So T equals 10. Wait.
What?
What?
Don't even.
Where did you get that?
Not yet. You are way too far ahead of us. Alright, so first of all, we are going to do the limit as delta T approaches 0. And so remember what ultimately is getting plugged in is this T plus delta T. So this is going to be 200 times 30 minus T plus delta T is what I'm going to write for now, squared, minus 200 times, what goes in the second one? F of T.
Yeah.
Which T is 10, right? Yeah, T is equal to 10.
Where did you get that from?
The problem.
Oh, okay. I was.
How fast is the water running out at the end of 10 minutes?
Oh, I didn't hear the 10. I was actually.
That's why. Yeah, that's why I said.
So times 30 minus 10 squared over delta T. So now, let's see. We are going to, I need to replace this. Was this 10 plus 0? I think, right? 10 plus 0. T and delta T.
It's folded.
Good job. Do you want a medal?
It's like a good fold.
It is a good fold, actually. Wait, is it like perfectly?
Hold on a second.
Do you want to like both sides and eat?
That's what I'm talking about. The not very good. It's the fold. It's perfectly folds every time. I think it's
Oh.
better than that. None of these are ones, so.
Also, I have this squared in the wrong spot. I was like, something isn't right. That squared should be there. Because now I can take a 200 out, and I'm left with 30 basically minus t and 30 minus t here. Hold on a second. Oh, wait. Just disregard this. This is for part 2. I'm getting ahead of myself. We're coming back to it, but it's for part B of the question. So just disregard what's written here for the next quick second. Because the first part of what we need to do for A says, how fast is the water running out at the end of 10 minutes? So I just need to do the instantaneous rate of change at that exact minute. So I'm going to take the derivative of the original question.
Okay.
That's why I was like, wait a second. This is for part 2, which is why I was getting confused. So I can take the 200 out, right, because it's a constant. So I don't really need to account for that in the derivative. It's just going to multiply everything by 200 at the end. So right now I have 200 times what is, because right now you don't know how to take the derivative of this, what is 30 minus t times 30 minus t? Like FOIL it. In chapter 4, you'll know how to take the derivative as it sits, and it's actually really easy, but I'm not going to teach you that yet because you'll get confused.
900.
Yeah. Just for reference as to what we're doing.
900 plus
or plus 60t.
minus 60. Plus t squared.
Yes. So then now I'm going to basically take the derivative of the pieces and then I'm going to multiply it by 200 because it doesn't matter what order I do it in. So what is the derivative of that? It's going to be 200 times what? So basically what's the derivative of what's in red?
Okay. Negative 60 plus 2t.
So then now I can multiply by 200. So this is going to be negative 1,200, no, 12,000 plus 400t. So that's just it simplified down. And then I want it specifically at 10 minutes, so that means I'm going to replace t with 10. So negative 12,000 plus 400 times 10 is going to be what? Negative 8,000. And this is the rate at which it's running out, which is why it's negative. So basically it is running out at 8,000 and it's in gallons per minute. Okay, that was the information was given to you in the problem to be able to figure that out. So at what in the
Whoa.
whatever. It's just not meant to be rectangled off apparently. So at the end of 10 minutes, it is running out at 8,000 gallons per minute. Okay. So now then, what is the average rate at which the water flows out during the first 10 minutes? This is where now we're going to use what we started with up here. So this is going to be, let's see, part B here. 200 times 30 minus 10 minus 200 times, it's just 30. So kind of disregard what's written up there because it's a little confusing. Because we actually need, it's a slight difference. Is this the right formula? Well, I'm just not sure that the answer I have on my paper is the right. Hold on. I think I have the wrong work on my paper. That's why I'm confused. Let me check something really fast before I have you write all this down and it's wrong. Okay, it's this formula here. It's this one. Not this one, which isn't significantly different, but it is a little different. We're not actually taking the limit. So we're doing this one here. So, it still doesn't make sense for that answer though. What is happening? I think there might be a typo on this problem because f of t plus delta t. What is the average rate at which the water flows out during the first 10 minutes? So delta t would be 10, right?
That's what's the change in time.
Yeah. So that means t has to be 0. But
So do we do
no, it is this. It is this one. It is this one. I just need to stop looking at my paper because there's too much going on in the paper that's not written correctly. Okay, it is the first one because t is 0. So this is 30 minus, this is delta t because t is 0. Okay, because it's like 0 to 10 because our initial time is 0. So during the first 10 minutes, the initial time is 0, so delta t is 10. There we go. So then this is minus 200 times, it would be 30 minus 0, so it's just 30 squared, over delta t, which is just 10. So then now we have 200 times 20 squared, which is 80,000 minus 200 times 30 squared is all that, 180,000 divided by 10. So that's going to end up being 80,000 minus 180,000 divided by 10, which is going to be negative 10,000. And so that means that it is, on average, over the first 10 minutes, running out at 10,000 gallons per minute. So at 10 minutes, which was part A, it's running out at 8,000 gallons per minute. But on average, during the first 10 minutes, it was running out at 10,000 gallons per minute. So this was at 10 minutes. And this was over the first 10 minutes, the average that it was running out. Fix this on my paper really fast so that it's not confusing. All right, I think we're going to stop there because that gets to the next thing of problems here. We should be able to wrap it up tomorrow, though, and be done with this section. So.
The rest of the problem.